right. And we are live, ladies and gentlemen. So I shall now attempt to locate my thesis. I'm just going to read this thing verbatim. Well, mostly verbatim. Generally, I'm trying to see, I need to edit stuff, and I'm having a hard time just sitting here reading through it. Just the text. I'm just sitting here reading it to myself. It's going to be a lot easier if I read it out loud, and it's easier for me to keep motivation if I at least have an idea that somebody out there might be watching me, which is rare here on YouTube, but oh well. It keeps these videos around. Maybe somebody will someday come across it. So the title of my thesis here is Using Experimental Archaeology and Microartifacts to Understand Cooking Features at Dust Cave. A thesis submitted to the School of Graduate Studies and Research in partial fulfillment of the requirement for the degree Master of Arts. See Samuel Edwards, Indiana University, Pennsylvania, August 2023. Title: Using Experimental Archaeology and Microartifacts to Understand Cooking Features at Dust Cave. Author, thesis chair, thesis committee. The potential of archaeological features to help understand of past cultures. To help understand past cultures is often understudied, has been, is understudied. Likewise, microartifact analysis, or MAA, is often overlooked, but has demonstrated the potential to add more information to our understanding of a site than larger artifacts alone. This project will examine microartifacts from features at the archaeological site of Dust Cave, a late Paleo-Indian through Middle Archaic site in the Middle Tennessee Valley. Previous research has investigated features using a variety of methods, including micromorphology and geochemistry, in addition to morphological analysis of feature shape and size. This has yielded a more complex understanding of site activity, underscoring the value of an integrated approach. Recent analysis of microartifacts from Dust Cave feature fill has demonstrated the potential for MIA microartifacts analysis to further clarify hearth use at the site and provide a more nuanced understanding of prehistoric cooking technologies and diet. This project will also involve experiments designed to test hypotheses generated from microartifact analysis regarding prehistoric cooking, diet, and processing methods at Dust Cave. That's abstract. Now here's a signature page. Associate professor, advisor, associate professor, blah, blah, blah. Like to acknowledge the original excavation teams that worked at Dust Cave from 1989 to 2002, and all of the field work that was involved in the recovery of the artifacts analyzed herein. Thank you to my advisor, Dr. Laura Holmesy Messer, and the other members of my thesis committee, Dr. Andrea Palmiato and Dr. William Chadwick. Also thanks to Sabrina Sepulveda, not sure how to pronounce her last name, for helping with microartifact analysis. Thanks to Andrew Mahaltra and Christina Gogler for helping with various thesis-related questions. Thank you to Dr. Nigel Bresch at Ashland University, who gave me my first introduction in archaeology as an undergraduate. Thank you to my mother, Lucinda George, Dr. Lucinda George, for assistance and encouragement along the way and for making graduate school look easy. Also, thank you to my grandmother, Margaret George, for her assistance and encouragement, and to my late grandfather, Paul Dean George, who taught me, among many other things, the importance of not taking things too seriously. Finally, and above all, I acknowledge the one to whom all credit is due. Unless the Lord builds the house, the builders labor in vain. Psalm 127, verse 1. Table of contents. List of figures. List of tables. Introduction. Chapter 1. Introduction. Caves and rock shelters provide long-lasting and effective protection from the weather, resulting in a long history of human occupation. These shelters have been attractive to people for millennia. Spelled that wrong. And are still utilized today by many contemporary cultures. The sheltered environment of these sites also aids in the preservation of the features and artifacts that they contain. Those shelters that are formed in limestone have another advantage to preservation in that the chemistry of such an environment reduces acidity, slowing the loss of organic material. An example of such a site is Dust Cave, a limestone cave located in northwestern Alabama, associated with an occupation history spanning approximately 7,000 years. We believe all that. Here, site conditions allowed for the exceptional preservation of many types of features. This included not only the preservation of organic content, such as small bones and botanical specimens, but also micromorphological aspects. For example, the features located at Dust Cave retain distinct microlenses of ash, which contain intact calcitic pseudomorphs of plant species. This project will take advantage of the information potential contained in the features of Dust Cave to address several objectives. First, it will provide a more nuanced look at hearth features from Dust Cave and subsistence strategy and diet of those who live there. This will help to give insight concerning the cooking methods of early and middle archaic inhabitants, as opposed to a simple recounting of what was eaten and when. Second, it will work towards developing a more nuanced typology for features. This is an area of archaeological analysis that needs refinement. Classification of features rarely receives the same level of attention as artifacts such as lithic tools, yet features are very important sources of information regarding diet and cooking technologies. Finally, this research will explicitly address the use of snails in the diet of pre-contact Native Americans in the Middle Tennessee River Valley, a subject of some debate. In a broader context, this will help to elucidate our understanding of the role of snails in the diet of Paleo-Indian and early archaic North American diet. Of in the diet in the Paleo-Indian and early archaic North American diet. Overall, the research will provide clues concerning the subsistence economy of the Middle Tennessee Valley during the transitional years between the Pleistocene and the Holocene. Microartifact analysis. One microscale technique that has proven useful in the study of features is microartifact analysis. Microartifacts, as the name implies, are small artifacts and have been more specially defined as those measuring less than 6.35 millimeters, i.e., the standard 1/4 inch mesh screen size. Among the first published examples of microartifact analysis in archaeology is Gifford's 1916 article reporting his investigation of shell mounds in the San Francisco Bay Area. Gifford used three sizes of mesh separating artifacts into three size grades: 1 to 2 millimeters, 2 to 4 millimeters, and 4 to 12 millimeters. He found that the different types of artifacts were noticed in different abundances depending on the size grade, thus indicating that different information is to be found depending on the size of the artifact being studied. Cook and Triganza in 1947 recognized the potential of microartifacts to give more detail in the investigation of shell mounds. In 1973, Judith McKellar, undergraduate at the University of Arizona, observed that smaller materials have a greater tendency to be primary refuse than larger objects, such as, e.g., more likely to remain in the place originally dropped or discarded. This became known as the McKellar hypothesis and implies, once again, that microartifacts contain different information. The larger artifacts. Multiple studies have further demonstrated the potential of microartifact analysis to add more information to our understanding of the site than the study of the site's microartifacts alone. Examples of this enhanced data include the identification of activity areas through the analysis of microdebitage from a lithic scatter, information concerning the function of mound construction surfaces at Poverty Point through types and relative abundance of microartifacts, and information concerning the function of hearth features at Dust Cave through microbotanical, microlithic, and microfaunal analysis. Thomas and Menino found that examination of faunal remains at the 2 millimeter size grade contributed significantly to the count of the gastropods, patella species, and Forcus lineatus in their research. Concerning mollusk analysis, they suggest, quote, careful recovery of potentially fragile shell fragments down to at least the 2 millimeter size fraction for accurate determination of the numbers of identifiable specimens of each species represented. Despite the potential of microartifact analysis, it is still too often overlooked as a technique in the archaeologist's toolkit. Indeed, following such experimental and methodological studies from the 1970s through the 1990s, interest in microartifact analysis decreased notably. In the past decade, an attempt has been made to revive the use of microartifact analysis and to make it mainstream. I wrote that about 4 years ago. I wonder if, past decades now didn't, make it mainstream. In addition to the research objectives described above, it is a goal of this thesis to give support to that attempt by further showing the importance of microartifact analysis. Holmesy and Capo in 2006 investigated features at Dust Cave using a variety of methods, including micromorphology, macromorphology, and geochemistry. This integrated approach has yielded a more complex understanding of site activity by proposing more specific uses for hearth features and demonstrating the importance of mass resource processing to site occupants. Recent work has demonstrated the potential for a microartifact analysis to further clarify hearth use at Dust Cave and has strengthened support for the hypothesis that gastropods were a part of early and middle archaic diet in the Tennessee River Valley. It is hypothesized that much information is still to be discovered from the feature microartifact at Dust Cave. Both microartifact analysis and detailed feature studies are an underutilized tool that have the potential to yield more data concerning our understanding of archaeological sites. A third potentially important yet undervalued means of interpreting assemblages is actualistic experimentation designed to replicate hypothesized activities at a site. Combining all three approaches, this project looks at the microartifacts from hypothesized hearth features, using data generated from experimentation to aid in the classification of typology. Specifically, 3 types of hearth features will be investigated concerning their potential function in the processing of nuts and snails during the Middle Archaic habitation Dust Cave. Previous feature research at Dust Cave. The analysis of features has resulted in the hypothesis that 4 distinct hearth types were used at Dust Cave. The archaeological remains of these features have been referred to as 1. Surface hearths, 2. Fireplace breakout features, 3. Subsurface pit hearths, and 4. Expedient hearths. A general description of each is as follows. Surface hearths, see figure 1, tend to be approximately 1 meter in diameter, extending to a depth of about 15 centimeters. They are occasionally lined with rocks and usually contain a significant amount of charcoal. They appear to have been burned at relatively high temperatures. Holmesy et al. In 2010, Burgess in 2018 relate these features to an ethnographically recorded technique in which animals would be placed on racks or impaled on sticks and exposed to the heat of the fire to cook. Fireplace breakout features, figure 2A, are small, about 30 centimeters across, and only about 5 to 6 centimeters in depth. They contain little ash, but much charcoal, and appear to have been burned elsewhere and pre-deposited instead of being burned in situ. It has been hypothesized that these features represent coals scraped from cooking features. Expedient hearths, figure 3, are characterized as smaller features approximately 40 centimeters across and extending to a depth of less than 10 centimeters. Dust Cave contains many examples of intentionally prepared surfaces made of clay. These clay surfaces retain the imprint of textiles, figure 3b. Expedient hearths are found on top of these clay surfaces Combustion temperature appears to be lower than that of the surface hearths, where layers of ash and charcoal suggest that these features are the remains of a cooking technique whereby fish and possibly nuts and mollusks were roasted in hot coals over the clay surfaces. These hearths may have also been used to parch nuts. However, there's a current lack of data on this type of feature, and their exact purpose is not fully understood. Subsurface pit hearths, figure 4, vary in dimension from 50 centimeters to 1 meter across and from 15 centimeters to 30 centimeters in depth. Despite the varied dimensions, the ratio of width to depth remains similar at 3.5. It's a ratio. Partially combusted material suggests that the features were burning at lower temperatures. Chemical analysis revealed high ratios of strontium to calcium, which is um, suggested for food such as nuts or fish. Huh. Further, they morphologically resemble pits that have been identified with nut processing. It has been hypothesized that these pit hearths function either for boiling or parching nuts. Hollenbach's 2009 study of botanical remains from Dust Cave points to significant usage of acorn, hickories, and black walnuts. Gastropod, both aquatic and terrestrial species, shell has been found in significant amounts at Dust Cave, as indicated in published literature. Spelled typo. Specific gastropod taxa identified include Procera caniculata, Viviparus georgianus, and Campyloma decisum. Gastropod is also noted on excavation feature forms. Apparently in greater frequency than the published literature might suggest. A recent pilot study by Burgess in 2018 analyzed microartifacts measuring 2 to 4 millimeters from the 4 feature types listed above. The DIAD-GAL examined 15 features, including 4 surface hearths, 4 expedient hearths, 4 pit hearths, and 3 rake-out features. Her research indicated that surface hearths and expedient hearths may have had a similar function. An even distribution of artifact classes within both feature types suggested that both surface and expedient hearths were multi-purpose. Interesting. We'll come back to that later. An abundance of shell and bone in these suggested that they were involved in the cooking as mammals, fish, and shellfish. I say, mammals, fish, and shellfish. The pit hearth assemblages were mostly shell and charcoal, suggesting that they were used to process both nuts and snails. There was more charcoal than shell, much of this being nut charcoal, suggesting that the processing of nuts was more common in these pits than the processing of shellfish. Nonetheless, there was still a notable amount of gastropod shell in the pit hearth features. This lends support to the idea that, in addition to nut processing, these hearths might have been used to boil snails. More charcoal than shell. Amount of gastropod shell, okay. This is intriguing because snails have been identified in significant quantity at Dust Cave and elsewhere, yet there is much about their place in paleo diets that is not well known. The fireplace rakeout features contained an assemblage that was more than 80% burned bone. This lack of diversity suggests that the features may not represent secondary deposits of refuse from the surface hearths, which contained a more diverse assemblage. So we see a significant decrease in the lithics in the surface hearths, and if surface hearths are a general purpose thing, sitting around the fire is flint knapping, and then there's presumably less flint knapping going on in the later occupations than in the earlier occupations, presumably. Um, where was I? Just checking to see if I had a bunch of adoring fans yet. I don't see them. Reverse assemblage. Experimental archaeology. In an effort to better understand cooking technologies used by pre-contact populations at Dust Caves, several experiments have been conducted. An experimental study in 2002 involved the cooking of fish on replicated clay surfaces similar to those hypothesized to have been part of the expedient hearths at Dust Cave. This study involved two separate experiments. The first experiment, see Figure 5, sought to determine the ability of prepared clay surfaces to be used for cooking through replication of the proposed cooking technology. Four such surfaces were prepared, three of which were fired with a hardwood fire built directly on the surfaces. The fourth was heated using hot coals from two of the former surfaces. In all cases, the coals were cleaned from the surfaces before food items such as catfish, beef, and popcorn were placed upon them. Figure 5c. While the beef cooked with mixed success, ranging from rare on the fourth surface to medium on the surface number tres. Using this method, the fish did not cook, and the popcorn, with the exception of one kernel on surface number one, did not pop. And moreover, the fish and beef had a tendency to stick to clay surfaces number one and number two, a situation that was remedied by leaving a thin layer of ash on surface number three before placing food items similar to what has been observed archaeologically. The second experiment, see Figure 6, involved a more indirect method of cooking in which fish was wrapped in sassafras leaves to aid in cooking. Two surfaces were prepared. On the first surface, a fire was built and the coals removed before placing a leaf of rapid channel catfish. This was then packed in clay and covered with coals and the fire rebuilt. A largemouth bass was cooked in a similar manner on the second surface, except that it was not packed in clay before rebuilding the fire. These, whoops, these clay surfaces function well to cook both the catfish and the bass. They did. The bones of the catfish remained unburned. Few of the bass bones were charred, despite the fact that the largemouth bass showed some indication of direct exposure to the fire. This correlated with earlier research at Dust Cave that found most of the funnel assemblage there was not discolored by fire. The experiments demonstrated the efficacy of roasting fish using coals and prepared clay surfaces and provided a material correlate to field observation. Here's some picky tours that you can't see. That guy's shirt's all ripped up. Oh well. As part of a 2010 experimental archaeology course, and inspired by the hypothesis that the dust cave pit hearths functioned as nut boiling technology, students at Murray State University conducted a study involving both experimental archaeology and microartifact analysis. A total of 70 nuts, hickory and black walnut, were crushed and boiled in a laboratory setting. Following both crushing and boiling, nutshells were compared to see if there was a difference in their fragmentation based on nut species. The method of crushing used nutting stones or mortar and pestle on the individual doing the crushing. No significant difference was found following the crushing stage when comparing the variables of crushing technique or the human processor. However, there was a noticeable difference in the size distributions between walnut and hickory, with hickory fragments tending to be smaller than the walnut fragments. This size difference was noticeable in the larger size grades, that is, greater than 4 millimeters, but did not seem to be apparent in the micro artifacts. Following the boiling stage, hickory fragments were found to have further decreased in size with an increase in the 2 to 4 millimeter size grade, while black walnut fragments did not. Noting the abundance of gastropod at the Hayes site in Tennessee, Cripple and Maury analyzed specimens of Plurocera canuliculatum taken from the nearby Duck River for nutrient content. They found that these snails provided only half of the calories contained in deer, and moreover, to approximate the quantity of meat contained in one deer, it would take literally tens of thousands of gastropods. Although at first glance this may appear to make gastropods an inefficient dietary choice, they also found that P. canaliculatum canaliculatum contain water-soluble vitamins such as riboflavin and niacin, and are a relatively significant source of calcium, iron, sodium, phosphorus, and potassium. Few other resources available to hunter-gatherers would have been as rich in these important minerals. Klippel and Maury point out that iron deficiency could have been a serious issue amongst hunter-gatherers, one that may have been especially pressing for women and children. They hypothesized that stone boiling may have been used to prepare a nutrient-rich broth from the snails. Experimental cooking of snails in North American context is rare in the literature. Reed, in 1962, however, reported on the experimental cooking of snails. And experimental cooking of snails understand the role that gastropods played in the diet of people living in prehistoric Iran. In this case, he and colleagues boiled two species of snail for 15 minutes, ate them unseasoned, and found both to be palatable. They used microliths to aid in extracting the meat from the shells, but apparently did not attempt making the broth. Making a broth, as Klippel and Maury later suggested. Madison, in 1959 and 1095, notes that extended boiling eventually causes the colored epidermis to flake away from the rest of the shell. In such a case, careful examination of the snail shell might be able to aid in determining the period of the method of cooking used for them if they were indeed cooked. However, Reed points out that this extended boiling might not be required to cook the snails. Current research questions and hypotheses. Previous work has presented many compelling hypotheses regarding the interpretation of hearth features, excavated a dust cave, and has demonstrated the potential of experimental archaeology and microarchaeology to aid in understanding them. These hypotheses include one that the features previously labeled by archaeologists as pit hearths function to process nuts and snails by boiling in skin-lined pits. Two, the clay hearths that have been termed expedient hearths represent griddles used to steam snails and process nuts. And three, these features are distinguishable from each other and from the third type classified as surface hearth through the analysis of microartifacts. Based in part on these hypotheses, the project will look specifically at the technology involved in nut and snail processing. The research questions being addressed in this thesis include the following. 1. Through a replication of possible past technology as informed by previous experimentation, microartifact analysis, and ethnography, what can be learned about the feasibility of the hypothesized nut and snail processing methods, roasting, steaming, and boiling using clay surface, expedient hearths, and pit hearths? 2. Do actualistic experiments produce an assemblage that correlates with what is found archaeologically? Can the experimental assemblage be used as a comparison when looking at that from Dust Cave? 3. How were pit and expedient hearths used in the processing of nuts and snails during the early and middle archaic occupation of Dust Cave? And 4. How did nuts and snails fit into the larger subsistence economy of Dust Cave during the early and middle archaic? That brings us up to page 25, and there's a comment from my advisor. This is all very well written, but the research questions coming not until page 25 seems very late in the game. Can we move these up at all? Okay, so here's the question. Can I move these up at all? Where would I put it? Wondering if there's a way to get them earlier than contextualize them with the other background presented. Oh my, I don't know. I mean, let's skip that one and come back to it. Summary. While analysis of features can be an important source of information concerning past cultures, features are often understudied. When they do receive attention, it is usually on a macromorphological scale, looking at visible morphology and artifacts. While this macro scale work has produced valuable information, there exists a level of data contained at a smaller level, at a smaller scale. In his 2010 book, Microarchaeology, Stephen Winger discusses the frontiers of microscale archaeology. In arguing for microarchaeological techniques, he notes that the difficulty of solving archaeological questions implies that researchers should exploit every possible means to answer them. This thesis works towards that goal, using the microartifacts contained in the feature field recovered from Dust Cave to gain more insight into cooking technology used at the site during its occupation. Chapter 2, Background. Dust Cave, Environmental and Cultural Setting. Dust Cave, see Figure 9, is formed in the limestone cliffs that line the Tennessee River at Pickwick Lake, an area of water impoundment resulting from the construction of Pickwick Landing Dam in 1938. Before the impoundment of the Tennessee River, this stretch provided excellent habitat for a large variety of mussels, as did the surrounding creeks and streams. This site is located in the Highland Rim section of northwest Alabama's interior low plateau province. Regional geology is characterized by Tuscumbia limestone and Fort Payne shed. The local Fort Payne shed provided most of the lithic material to the inhabitants of Dust Cave throughout its history of occupation. Streams, springs, and sinks are found throughout the neighboring upland area. Nonetheless, the interior of the cave probably provided a dry environment for most of its human occupation. Yes, I do slip into other voices at times. It's hard to sit here and read for this long without entertaining my voice in some way. Archaeological investigation began at Dust Cave in 1989. This is part of an assessment of caves undertaken for the Tennessee Valley Authority, the cultural resources contained in these caves being in potential danger of degradation due to the fluctuating levels of the Pickwick Basin Reservoir. The original 1989 investigation involved the digging of 5 test pits, resulting in the discovery of cultural material. Excavation continued in the following summers, opening a total of 7 test pits and digging until bedrock was reached. Excavations during the following 3 summers opened a 12 by 12 2-meter trench that allowed for examination of the stratigraphy. This was then divided into stratigraphic zones, labeled A through Y, with A representing the youngest deposits and Y representing the oldest. This organization was used to guide further excavation, which was done in 5-centimeter levels within each of the zones. Excavation continued during the summers from 1996 to 2002. The earliest evidence of humans in Dust Cave comes from radiocarbon dates and diagnostic artifacts contained associated with Middle to Late Paleo-Indian occupations. The cultural components include Quad, Beaver Lake, and Dalton, although Dalton is thought to span Pleistocene Holocene transition. It has been considered to be a part of the Paleo-Indian occupation of Dust Cave based on patterns of land use and technology. Artifacts recovered from the Paleo-Indian component of Dust Cave include bifaces and a significant quantity of unifaces, including gravers, scrapers, and blades. Bone tools include owls, antler tines, and a needle. A perforated raccoon tooth was also associated with this component. Also, a possible bone bead was found in association with either the late Paleo-Indian or early side-notched components. The most common features representing activity at Dust Cave during the late Paleo-Indian occupation are charcoal pits and stringers. While that does not hold true for charcoal stringers, charcoal hearths continue to be the most frequent feature type throughout the identified components of Dust Cave. There are also prepared surfaces, 2 possible surface hearths, and 1 expedient hearth. In her analysis, Holmesy in 2010 identified 32 features associated with the Paleo-Indian component. Now, the early archaic is represented by early side-notched and Kirk corner-notched components at Dust Cave. Projectile points from the early side-notched component resemble the big sandy Taylor and Bowen types found in the southeast. Bone tools included antler tine and owl fragments and possible bone point. Holmesy identified a total of 32 features among the early side-notched assemblage. Charcoal pits, hurricane, and numerous feeders, comprising 44% of the total. Fluvial activity and decalcification prevented the identification of many of these charcoal pits, although the abundance of fish bone in some of them suggests that they may have been expedient harbors. Rock-lined pits are in addition to the feature assemblage. Post-depositional events appear to have resulted in the loss of intact cultural deposits between the early side-notched and Kirk-stem components in Dust Cave. Few Kirk corner-notched points were found, and the early side-notched components appear to be truncated. The time span thus affected appears to be between 8,800 and 8,000 Cal BC, as reported to Holmesy 2010 and Sherwood et al. 2014 anyway. However, there's a mixed deposit zone Q not shown in figure 2 that contains early side-notched, Kirk corner-notched, and Kirk-stemmed artifacts. The middle archaic is represented by Kirk-stemmed. Kirk-stemmed. Not Kirk corner-notched, right? Eva Morio Mountain and Benton components. Although it may be more accurate to say that the Kirk-stem components occurs at the transition between early and middle archaic at Dust Cave. The Kirk-stem component is associated with zone P of the stratigraphy. Now, early side knot, Kirk corner not chain stem. Most of the Kirk-stem points are serrated, and 2 Kanawha points were found within the Kirk-stemmed component. Notable inclusions to the tools recovered from this component are pitted nutting stones and bone fish hooks. Another perforated raccoon tooth was found here as well. A total of 5 pit hearths and 8 expedient hearths are associated with the Kirk-stem component. And there's also one large feature that may represent another of them. 3 human burials from the Kirk-stem component are the earliest found from Dust Cave. In all, Holmesy identified 53 features in the Kirk-stem assemblage. The Eva Moro Mountain component of Dust Cave occupies 4 stratigraphic zones, N, K, J, and E. A significant amount of human burials was found at the contact between Zone N and Zone P. Human activity appears to have decreased during the deposition of Zone N, but returned through K, J, and E. Overall, the Eva Moro Mountain component appears to have been a time of extremely intense occupation. Meanwhile, the absence of storage features a decrease in diversity, and a decrease in spatial segmentation suggests that the length of stay was shorter than had been the case during the Kirk-stem components. There are 193 features identified for the Eva Moro Mountain component. These include 13 surface hearths, 15 pit hearths, 9 expedient hearths, and 3 canine burials. There are also 13 human burials. In addition to stemmed Benton points, the Benton component in Zone D contained Moro Mountain, Crawford Creek, and Sykes White Creek point types. Groundstone pestles were also recovered. Human occupation during the Benton component appears to have been moving closer to the cave entrance, likely because the headroom in Dust Cave was diminishing by this time. The cave was abandoned around approximately 3600 Cal BC. Supposedly, a total of 27 features were identified among the Benton assemblage. These include 3 surface hearths, 3 expedient hearths, 1 pit hearth, and 1 canine burial. 3 human burials were also discovered. Paleo environment. The end of the Paleo-Indian period in the southeast is associated with the transition between the Pleistocene and the Holocene, and the ending of the Younger Dryas around approximately During this time, the region experienced a warmer and wetter climate, bringing about changes in plant and animal communities. Forest compositions experienced a decrease in spruce and fir trees and an increase in more temperate communities of trees, such as oak and hickory. Many of the Pleistocene fauna became extinct during this time, including horses, camels, and some of the more cold tolerant fauna, such as mammoths and ground sloths. An increase in artifacts and number of sites suggests a possible increase in the population of the Southwest during the early Archaic. Although the extent to which early Archaic and late Paleo-Indian lifeways differed is a matter of some debate. It has been thought that early Archaic peoples were less mobile than Paleo-Indians. Lithic sources became more localized, as did point styles. Still, the people of northwest Alabama during the early Archaic would likely have been relatively mobile, living in family groups between campsites that were occupied for a period of days or weeks. Groups would occasionally join with other family groups and regularly meet as part of larger gatherings of several hundred people. Their subsistence economy was built on a generalist strategy of animal and plant procurement. Nuts were a significant part of this strategy. In northwest Alabama, hickory nuts appear to have been a favored resource. One of the notable differences between late Paleo-Indian and early Archaic tools is the appearance of side and corner notches on points. Notches along with serrated edges began to appear during the late Paleo-Indian and may be related to the extinction of megafauna and the resulting change in hunting strategy to smaller animals. Meanwhile, the tools associated with the early Archaic appear to have been produced with a greater focus on expedience than the Paleo-Indian toolkit and are more likely to have been constructed of a lower quality material. This may be related to the development of a more generalist subsistence strategy. Other tools related to early Archaic point to activities involving woodworking, fish procurement, and plant processing. The transition between the early and middle Archaic periods is temporally associated with the hypsithermal event, a period of warmer and drier conditions in the southeast, accompanied by a slowing of the rate of sea level rise. These conditions are probably related to stabilization of aquatic habitats with the formation of backwater sloths, however you pronounce that, and shoal environments. This, in turn, likely resulted in an increased focus on aquatic resources for subsistence. Shellfish would have been a part of this increased focus. So that's between early and middle Archaic. Thriving in the developing shoals. The warmer and drier climate also encouraged the spread of nut producing trees such as oak and hickory. This is evidenced by pollen reconstructions, and the change in hickory and oak is illustrated in Figure 8. Culturally, the Middle Archaic is thought to be a time of increasing complexity. Populations continued to increase, leading to more population density and territoriality. Trade and violence were also apparent, violence being attested to by the condition of recovered human remains. Formal cemeteries began to develop, as did earthworks and mounds. While nuts remained a primary resource during the Middle Archaic, the faunal component of the subsistence economy became more focused on fish, shellfish, and deer. The beginning of plant domestication in North America began during the Archaic, and it is possible that members of the Eastern agricultural complex were cultivated during the Middle Archaic of the Mid-South with the development of floodplain habitats. In comparison to Paleo-Indian and early Archaic technology, stone tools during the Middle Archaic appear to have been less curated and more expedient in design, continuing the trend seen in the early Archaic, and are more likely to have been made of local materials. Stemmed points also appear during the Middle Archaic. Ethnobotany. Nutshell is a common ecofact in many eastern woodland archaeological assemblages. Hickory nutshell comprises a significant part of this, especially at archaic sites. This correlates with ethnohistoric observation and current nut use among contemporary Native Americans that indicates a long history of hickory exploitation. One of the earliest reports of Native American nut processing comes from Thomas Harriot's in Quinn 2017. In the 16th century, he records observing walnuts likely referring to hickory species as well, both of the family Juglanaceae, being broken with rocks, pounded with mortars, and mixed with water to produce nut milk and soup. This may have included boiling. In 1701, John Lawson and Fritz et al. 2001 mentions a dish of powdered hickory made by native people of the southeast, either served as powder or mixed with venison broth. Later in the 18th century, William Bartram, 1791, mentions a process by which they produced hickory nut milk involving first pounding and then boiling the nuts. Benjamin Hawkins in 1799 described that this process produced in both nut milk and oil, the oil separating and rising to the top of the mixture. For recent ethnographic research by Myra Perry gives some detail regarding hickory use in the production of traditional kanuchi, one of the many alternative spellings, by the Cherokee. This involves crushing hickory nuts and forming the resulting nut meal into balls. These are then placed into boiling water to form the soup. The separation of the shells is allowed to occur naturally at stage, which mitigates the difficulty of separating the meat and shell by hand. The book Cherokee Cooklore um, records a similar process. This recipe involves the use of a sieve to separate some of the larger nut shell before making the balls and mentions that the product can either be served as thick as a soup or thinner as a drink. Ethnomalacology. The consumption of snails has been mentioned in 19th century accounts of Native Americans in the Great Salt Lake and Fort Boise regions. However, there's limited published literature beyond this concerning the dietary use of terrestrial and/or aquatic snails among indigenous North Americans. There are some analogies globally. Contemporary Mayans collect and eat Pomaceae and Pachychilus snails. Pomaceae are prepared as a soup or roasted. Pachychilus are generally prepared as a soup. The spires of the snail shell are usually cut off before cooking to allow for the extraction of the meat when eaten. Indigenous inhabitants of Borneo employ a similar technique, breaking the tips from the spires. In addition to their role as a dietary component, gastropods have been used globally for a variety of medicinal applications. Many of these are related to anti-inflammatory purposes and used to treat maladies such as asthma and arthritis. They have also been used for wound healing and as a treatment for burns. Gastropods have been noted in archaeological contexts since the 19th century. Their presence has been attributed to diet in several cases. Um, Russell Cave in northeastern Alabama, and occupied from the early Archaic to the late Woodland period, is an example. This site contains an assemblage of freshwater mollusks that include snails. The most common of the snails found at Russell Cave include Goniabasis lacrata, Goniabasis angulata, and Pleuroceras caniculata. All of these were found with the ends of the shell spires broken off. G. laqueata, and P. caniculata were all found at all layers of the excavation. The Hay site in Tennessee contains a notable amount of gastropod shells. Approximately 900 square meters of the site is a shell midden, primarily gastropod dating to the Middle Archaic. Based on the pattern of deposition, quantity, and intactness, Klippel and Maury hypothesized that the gastropod deposit is anthropogenic. It has been speculated that the use of shellfish is a strategy used during times of resource stress, but gastropods are not only calorie poor, they would have been more difficult for the occupants of the Hay site to gather during the months of pursued scarcity. Gastropod shell has been found in association with burials dating as early as the Archaic period in the eastern woodlands. The marine species Busicon sinistrum, the lightning whelk, and Marginella were distributed throughout the Mid-South and are found in burial context as is the freshwater snail Leptoxus. Deposits of gastropods have been recovered from Black Cat Cave, an archaic site in central Tennessee. Perez et al. Suggests that these deposits, along with prepared clay surfaces similar to those found in Dust Cave, are related to mortuary activity and ritual feasting at the cave. Gastropods associated with human burial continues into the Mississippian period, and notable examples of snail shell included with interments are found at Cahokia. A summary of botany and malacology at Dust Cave. Analysis of plant remains from features shows an increase in plant remains. Throughout the occupation of Dust Cave until later habitation during the Benton component. See Figure 11a. By weight, the highest percentage of these remains are from hickory nuts. Figure 11b. Hickory nuts show a pattern of intense use from the beginning of the cave's habitation until its abandonment. A noticeable amount of gastropod shell has been observed at Dust Cave. Large concentrations are specifically noted in connection with the charcoal pit feature and a possible expedient hearth. Microartifact analysis has also revealed a high concentration of 2 to 4 millimeter gastropod shell in the feature fill of a surface hearth. The presence of these gastropod remains is still uncertain, but their abundance in cooking features, especially as microartifacts, lends evidence to their cultural use. Overall, the prevalence of gastropod shell is probably understated in the literature, especially due to the lack of microartifactual analyses that would help to clarify the status as a cultural or commensal species. In a broader context, what is known about Dust Cave subsistence tends to follow the general trend seen across the southeast and eastern woodlands as a whole. This includes changes in diet that indicate an increasing interest in nuts and other plant resources, as well as the increasing focus on aquatic resources during the Hypsothermal and into the Middle Archaic. Additionally, the somewhat more enigmatic presence of gastropod shell is consistent with the Archaic of the Southeast. Chapter 3 Methods. Excavation took place at Dust Cave between 1989 and 2002. Over 400 features were identified at the site, including 19 pit hearths, 25 expedient hearths, and 21 surface hearths. Excavators removed feature fill by trowel and processed it on site using a modified SMAP type flotation machine and separated into heavy and light fractions. The samples were stored at the University of Tennessee's Archaeological Research Laboratory. Following the completion of the excavations in 2002, some heavy fraction had to be refloated using a float tech unit at Indiana University of Pennsylvania's Department of Anthropology to remove clay that was still adhering to some of the materials and interfering with the identification of microartifacts. The methods utilized in this thesis include 1. Analysis of microartifacts recovered from Dust Cave and the features of Dust Cave. 2. Experimentation designed to replicate 2 types of cooking methods inferred from the archaeological features. And 3. Analysis of microartifacts from the cooking experiments. Sample selection. Samples analyzed in the study were taken from the heavy fraction of flotation samples from the excavated features at Dust Cave. The features examined 5 expedient hearths, 4 surface hearths, 6 pit hearths, and 1 feature identified as a rock basin. Some samples needed to be floated a second time on campus. At Indiana University of Pennsylvania, either because they had been previously unfloated or because the heavy fraction was not free of dirt to the extent where accurate sorting was feasible. For analysis, feature samples were selected in an attempt to represent as even a distribution as possible across the history of early and middle archaic occupation. An expedient hearth and a pit hearth from the early side notch component, 2 pit hearths and 2 surface hearths from the kirk stemmed component. 3 expedient hearths and 3 pit hearths from the Evamora Mountain component, and 2 surface hearths and 1 expedient hearth from the Benton component. Data from the pilot study by Burgess in 2018 were included in the data analysis. The rock basin is found in the Paleo-Indian component, and an additional feature identified as coals and ash pit was from the Evamora Mountain component. The samples analyzed in this study, as well as those analyzed by Burgess, were on load from the University of Tennessee and have since been returned. So that's interesting, isn't it? Hmm. There's supposedly a pit hearth showing up in the early side notch. I don't know. Laboratory analysis. The heavy fraction from archaeological features was the subject of the microartifact analysis in this thesis. Using nested geological sieves, the heavy fraction was sorted into the following size grades: less than 1 millimeter, 1 to 2 millimeters, 2 to 4 millimeters, and 4 to 6.35 millimeters, and greater than 6.35 millimeters. The geological sieves were shaken by hand because of the possibility of damaging microartifacts through the use of a mechanical shaker. Due to time constraint, large floats were subsampled at 50% using a standard geological sample splitter manufactured by Humboldt Manufacturing Company. Previous work suggests that such a 50% splitting of microartifact samples yields results that are similar to a 100% sample. Microartifacts were hand separated under 2 to 10x magnification. I hope I multiplied that. Probably, right? Microartifacts were hand separated under 2 to 10x magnification. Those artifacts falling into the size grades of 2 to 4 millimeters and 4 to 6.35 millimeters were sorted into categories of burned bone, unburned bone, muscle shell, gastropod shell, seed, lithics, nut charcoal, and wood charcoal. See figure 13. Charcoal that was not readily identifiable with low magnification was classified um, as unidentified charcoal. Shell was distinguishes muscle shell by thickness and the layering of calcium carbonate. Gastropod shell was identified as thinner and unlayered, and often curved. In some cases, fragments of the spiral structure of the cell were always left intact as well. All gastropod remains were counted as gastropod, whether they were aquatic or terrestrial. Classification on a more specific level was beyond the scope of this investigation. Nut charcoal was distinguished based on its greater overall density and lack of parallel cellular structure seen in the wood charcoal. Unburned bone is light brown to tan in color. Bone is classified as burned if the color were dark brown to black or white to whitish blue. Again, a more specific taxonomic classification of bones beyond the scope of the study. Magnification included the use of an optovisor head magnifier and an icon binocular microscope. Magnification was mostly used to aid in the sorting of 2 to 4 millimeter size fraction and was usually accomplished with the head magnifier. Greater magnification with the binocular microscope was occasionally used to aid in some of the more ambiguous identifications, such as in the distribution between wood and not charcoal. The distinction. Once sorted, artifacts were weighed by category, and the weight was divided by the sample volume to obtain a standardized density in grams per liter. Sample volumes were obtained from scans of the original flotation logs kept by Dust Cave Archaeological Project personnel during the processing. This required a comparable review of the logs, as many soil samples had originally been processed in smaller batches, resulting in multiple separate entries for a single feature that needed to be summed, and the condition slash preservation of the handwritten notes occasionally required careful examination. Careful visual. Data, including size, grade, weight, and volume, are entered into the database using Microsoft Excel. Densities were calculated as the weight in grams of artifact type divided by the fraction sample analyzed per liter of soil sample originally floated. For example, weight of 1 gram and a 50% sample of the heavy fraction from a 2-liter soil sample would be a concentration of 1 gram divided by 0.5 times divided by 2 liters, which equals 2 liters per gram. No, 2 grams per liter. 1 divided by 0.5 divided by 2. Not sure that's right. Artifacts that were present but too light to be registered by the scale were recorded as less than 0.01 grams. For the purpose of statistical analysis and graphs, these were considered a concentration of 0 grams per liter. Calculation of ubiquity, they were reported as present. The concentrations of the artifact types were compared among the 3 feature types using both descriptive and inferential methods of data analysis. Descriptive methods included the construction of histograms and box and whisker plots to compare artifact concentrations within hearth types, between hearth types, and between occupational components. The ubiquity of each artifact class was also compared between feature types and occupational components. Inferential methods included the analysis of variance to evaluate the statistical significance and variations among the 3 hearth types and the 5 occupational components. Each of these analytical techniques was applied to the data from the 2 to 4 millimeter and 4 to 6.35 millimeter datasets. Experimental archaeology. Resource procurement and preparation. Hickory nuts and black walnuts were gathered by the researcher in fall of 2018. Nuts were procured from various locations in Indiana Borough in western Pennsylvania and the community of Cinnamon Lake in north central Ohio. A large number of dried black walnuts were also donated by Mr. Dave Saunders, a property owner in northern Ohio, and whom I should probably acknowledge in the acknowledgments. Gathered hickory nuts were left in their husks and laid out on a table indoors to air dry at room temperature. After some days, however, it became apparent that the nut husks were a habitat for small worms, and nut husks were removed to the remainder of the drying period. Removal of the outer husk was a fairly difficult task, but the bare huskless nuts were apparently less attractive to the worms. Once the husks had been removed, the hickory nuts were placed into fabric mesh bags and hung to dry. Husks from the freshly gathered walnuts also became wormy after several days and had to be removed. The husked walnuts were placed into baskets made of metal mesh to dry. As the experimental work was delayed for a year following the initial gathering of the hickory nuts, another batch was gathered in the late summer of 2019. Due to time constraints, the husks of these were not removed until a new set was required for the griddle experiments. However, breaking open the nuts revealed that many of these were still in good condition. Yeah, that's kind of clear, despite neglecting the drying steps required for do. Let's just say the husks of these were not removed. A new set was required for the griddle experiments. in October. Well, oh, 2019. Let's see now. The husks of these were not removed until a new set was required for the griddle experiments. Delayed a year following initial gathering of hickory nuts. Another batch was gathered in late summer of 2019. How about we just say another batch? Another batch of hickory nuts and left to sit in buckets for several months with no other preparation. Breaking open the nuts for the cooking experiments revealed that many of these were still in good condition despite neglecting the drying steps. Another batch of hickory nuts was gathered in late summer of 2019 and left to sit in a bucket in a garage for several months with no other preparation, i.e., husk removal drying. Breaking open the nuts for the cooking experiments revealed that many of these were still in good condition despite neglecting the drying steps. This implies that for short term storage, i.e., a matter of months, the careful steps taken to dry the hickory nuts may not be necessary. Moreover, removal of the husks was much more difficult early in the drying process rather than later. It is possible that the worms that feed on hickory nut husks, like those that feed on walnut husks, are not a threat to the nut meat itself and can be ignored, but this requires further research. The acquisition of bulk snails in the time frame of the thesis proves to be challenging. Most vendors only provide snails that have undergone a preparation that involves removing them from the shell and then restuffing them, often with added ingredients such as garlic and butter. Marine periwinkle snails occasionally sold in a less altered condition, and an attempt was made to acquire these as a proxy for the aquatic snails found at Dust Cave. However, these proved difficult to acquire in Ohio. Indeed, only two suppliers of marine periwinkle snail in the eastern United States were located. An attempt was made to purchase snail from one of these, but the vendor was unable to obtain them within the required time frame. Shipping costs associated with the second supplier were prohibitive for this thesis. As a last resort, 2 dozen escargot a terrestrial gastropod not native to North America were purchased from Classic Seafood Market in Cleveland, Ohio. These had unfortunately been pre-processed. Still, using these prepared snails for cooking at least gives an indication of what would be involved in the cooking of freshly gathered snails. And these were used in the first snail boiling experiment in 2020. A source of unprocessed helix species snails, Peconic escargot in Shrub, New York, it was located following an experiment. We used for a second boiling experiment in 2021. Preparation of cooking technology, pit and clay surface. An experimental replication included the reconstruction of one, a clay griddle designed for dry roasting nuts and for steaming snails, thus a replication of the expedient hearth, and two, a skin-lined pit used for boiling nuts and snails using fire-heated limestone rocks, thus a replication of the pit hearth. Construction of these features was based on the inferences drawn from previously described analysis of the expedient hearths and pit hearths at Dust Cave by Holmesy. The following describe the process of procuring and preparing the materials and the construction of the features. The pit hearth replication involved construction of a skin-lined pit in which both nuts and snails were boiled. A shallow pit measuring 50 centimeters in diameter by 15 centimeters in depth, roughly a dimension of the pit hearth excavated at Dust Cave, was hand dug with a spade and lined with a piece of buckskin leather obtained from glacial wear and unlined fur and leather supplier. Stones were placed on the edges of the leather to hold it in place. 3 cooking experiments were done via this method: boiling of crushed black walnuts, boiling of crushed hickory nuts, and boiling of snails. Snails were boiled in the same pit used for the nut processing, but separate from the nuts. The expedient hearth replication involved the construction of a clay surface upon which nuts were dry roasted and snails were steamed. The clay griddle was used to roast 30 hickory nuts, 30 walnuts, and 12 snails. Clay was donated by Indiana University of Pennsylvania. The clay had become hard and unworkable and required soaking in water to rehydrate prior to use. It was allowed to sit for several weeks to attain the right consistency. Following this process, the clay reached a stiff but workable consistency. It was placed on the buckskin and formed into a smooth rectangular griddle measuring that. The griddle sat indoors on the buckskin to dry for several days before use through hardening, though hardening was likely done through burning prehistorically. Hickory and walnut shell were used as fuel for steaming and roasting, proving to be an excellent choice for this purpose and readily available following the processing. Four variations of cooking were done using the expedient hearth method. One, black walnuts roasted using hickory nut shell as fuel. Two, snails steamed using walnut shell as fuel. Three, hickory nuts roasted using walnut shell as fuel. And four, walnuts roasted using walnut shell as fuel. Experimental cooking process. Nuts were processed in the pit hearth reconstruction following the methods described in ethnographic accounts. Different accounts of kimuchi preparation and nut processing have been described, but a common theme is crushing and pounding nuts, followed by dissolving in hot/boiling water. So, as the first step in the production of nut oil and nut milk, this part of the processing is what is replicated here using both hickory and walnuts. Did you actually make kimuchi or process nuts? Uh, well. Reading advisor's comments. So if you address that first one, be clear here, for example, the expedient hearth replication entailed construction of clay surface on which nuts were dry roasted and snails steamed open. Four variations were conducted. Is that what I said? Yeah, I think so. Hearth replication scale construction skin line pit. So I think I got this. So um, okay. Review. Accept. Preparation of canucci involves several steps. First, the nuts are cracked and the larger and more easily extracted shell fragments are removed. Much of the nut meat, especially hickory, is difficult to separate from the nut shell, but doing so is often omitted because the shell and nut meat naturally separate during the boiling, making hand separation redundant. The nut meat and remaining shell fragments are then crushed into a powder until the nut oil is released and a greasy mash is formed. Ideally, the consistency of the mash allows for the formation of balls, which is how kanushi is often prepared among contemporary Cherokee. The balls are then dissolved in boiling water and the nut shells drained before serving. In this experiment, nut preparation was accomplished using authentic nutting stones and a stone pestle. These were unprovenienced archaeological artifacts often used for educational demonstrations by Indiana University of Pennsylvania. Two nutting stones were available. One was smaller, with one shallow pit in the surface. The second was much larger, with several pits on both sides. A smaller nutting stone worked well for cracking smaller hickory nuts. Cracking walnuts requires more force than cracking hickory nuts, and this is more easily accomplished using the larger stone. A total of 100 hickory nuts were cracked on the nutting stone, which was placed onto a plastic sheet to catch the nut pieces. Larger shell fragments were removed and set aside for use as fuel, while the smaller shell fragments were pounded together with the nut meat to separate during the boiling step, as has been suggested by ethnohistoric literature. The more intense mashing step, pounding the nut meat into powder, was done in the pot using the hammer stone until greasy powder was formed. Uh, how about the remaining nut meat? Was pounded was pounded into powder into powder, while the powder became greasy. It in this case it did not, while the nut meat powder The nut meat powder became greasy. In this case, it did not reach a consistency that would a consistency. Let's say cohesiveness. It would allow the formation of balls. As mentioned above, the husks were left on the second batch of gathered hickory nuts until processing. In this case, the larger nutting stone having deeper pits proved useful for removing the husks from this batch. While removal of the husks was a difficult task and done by hand, it was made much easier if the nut was first placed into one of the pits and struck on one end with a hammer stone to loosen the husk sections from the nut. Pit boiling experiments. Before formal boiling experiments were conducted, the author gained experience with stone boiling through multiple exercises in a separate pit constructed for learning and practice. Learning and practice. There you go. Resolve. A plastic bowl with a volume of 2 liters and having markings of every 0.5 liter was used to transfer approximately 4 liters of water to the pit. Limestone rocks were heated in a wood fire nearby. Transferred to the pit with metal tongs, the rocks were periodically exchanged for freshly heated rocks, returning the previously used rocks to the fire for reheating. This procedure was repeated until the water was boiling. Since the preliminary exercises were conducted entirely to prevent the author from going to the formal experiments with no stone boiling experience, exact details are not recorded concerning these, but the method is similar to what is mentioned in published ethnographies. Formal experiments were conducted on private property in rural Ashland County, northern Ohio. Pit and expedient hearths were reconstructed according to the dimensions suggested by archaeological data from Dust Cave. The production of kunichi was done during October of 2019, while the cooking of the snails and the roasting of nuts in the expedient hearth was done in January of 2021. Really? Should be noted that nut processing would likely not have taken place during January in pre-Columbian Alabama. However, the timing of the experiments were influenced by time constraints of the thesis. Weather conditions played a role in January's experimental setup when rain and heavy wind became challenging. Time constraints of the thesis and time constraints of the thesis. Weather conditions played a role in January's experimental setup when rain and heavy wind became challenging. Thus, experimental conditions represent a worst case scenario for the techniques attempted. 11 limestone cobbles. Eleven limestone cobbles. All right. How about we? So we've got 11 limestone cobbles. Formatting. Wrap text. Top and bottom. Should be top and bottom. Why is it behind it? "11 limestone cobbles are gathered locally in the community of Cinnamon Lake, mostly from road fill. Oops. A fire was kindled from brush and tree branches used because of the availability of a large brush pile on the property, and the limestone pieces were placed in the fire to heat. Once the stones had been allowed to heat, they were removed with a pair of tongs and placed in the water. This was repeated until the water began to boil, at which point the ground nut mixture was added. Canucci was removed to the pit using the product was removed from the pit using a metal ladle. The broth was poured through a metal strainer when served to remove the remaining nut shell. Preparation of walnuts was done following a similar method as the hickory nuts. In this case, only 15 walnuts were used and half the amount of water. Who knows? Ah, 2 liters. I don't know. Something like that. All right, so we've got some formatting mess here. This is table 2, but this caption should go up here. There we go. There, for some reason, this won't go on that line, but I don't seem to be able to fix that, so okay. Snail boiling took place in January 2020 and again in January of 2021. The same pit was used that had been used in October 2019 for the Canucci preparation. Likewise, the same limestone pieces were used. Before use, the pit had to be drained of water that had collected. Snails were placed as purchased into the pit hearth with approximately 2 liters of water. The water was brought to a boil using the heated stones, and the heat was maintained in the pit for approximately 15 minutes. Maintaining the boiling temperature required the periodic removal and reheating of stones in the fire. The boiling process caused a large amount of water to be lost as steam, and care had to be taken to ensure that the snails remained in contact with the heated water throughout the duration. After the 2020 snail boiling experiment, another source of Helix species snails were located that not had been stuffed ahead of time, since there were some lingering doubts of the effectiveness of boiling during the first experiment, i.e., the snails were not consumed. A dozen of these snails were ordered, and the snail boiling experiment was repeated in January 2021. The remains from this cooking pit were carefully gathered and analyzed. The cooked snails were also consumed to verify that they had been well prepared. Expedient hearth experiments. A fire was built on the clay griddle to roast the walnuts and the snails. The weather became challenging to this end with heavy winds and rain that went on throughout the duration of the experiment. Even with an overhanging tarp, wet conditions were still a problem. The tarp kept the rain from extinguishing the fire itself, but the soaked ground led to the deterioration of the clay griddle. The griddle was then placed on a 2-inch high platform of scrap wood to keep it above the saturated ground, after which cooking proceeded without much further difficulty. By this time, however, the deterioration had caused the loss of at least 1/3 of the griddle. A sizable quantity of nutshell was left from the Canucci preparation, and a total of 15 walnuts were roasted in a mixture of wood and hickory nut charcoal on the clay griddle. Walnut shell was used as fuel to roast a total of 30 hickory nuts and to roast a batch of 15 walnuts. One snail was roasted as purchased on the clay griddle using a walnut shell. The remaining 11 snails were cleaned before cooking by scraping out the butter and garlic, stuffing, and washing the snails in warm water. After removal of the cooked material and allowing the griddle to cool to a manageable temperature, the cooking remains were gathered for analysis. Laboratory analysis of experimental artifacts. A representative sample of the remains from the clay griddle was collected following cooking experiments after enough time had passed to allow the griddle and its contents to cool. The artifacts from the reconstructed expedient hearths were then sorted into size grades of 2 millimeters, less than 2 millimeters, 2 to 4 millimeters, 4 to 6.35 millimeters, and blah, blah, blah. Within the 2.4 and 4 6.5 grades, artifacts were sorted into categories of nut charcoal, blah, 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 clay balls, and gastropod shell, blah, blah, blah. The artifacts were weighed and data entered in the database in Microsoft Excel. Unfortunately, the residue from the 2020 pit boiling experiments was not saved. This was due in part to some of the contents being accidentally discarded during the cleaning process, but after consideration, it seemed like the cooking process had preserved no artifacts being left in the pit used to use as material aids. The pre-processing had been done elsewhere, and the pit was lined with skin, and the skin emptied, cleaned after cooking, as it was in this case. Still, it's not rule out the possibility of residual contents, i.e., fragments of boiling stones, ash, charcoal, gastropod, blah, 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 would end up in or near the pit itself after cooking. Also, these microartifacts would be useful correlate in future studies. So, following the 2021 snail boiling experiment, the residue was collected and examined in the same way as the remains in the Eden Hearth experiment. Paragraph of the section. The whole chapter? This chapter is a little bit stream of consciousness, and at points hard to follow. You write well, which helps, but this chapter will need a bit of reorganization and clarification. Wait and see what the committee says. I expect they'll find it a bit confusing. Try to suggest a reorganization and try to make the side comments less of a side comment, more integrated. Oh, I don't know. Sort of. I did that a little bit, perhaps. Chapter 4 Results. Time is it anyway? Oh my, am I going to get this thing done tonight? So if I'm going to try to get this thing done and turned in tonight, which would be very, very nice, only way I can see myself doing that is by making tea and staying up half the night. That would be okay, but I feel the need to drive down to my apartment tomorrow. I have much stuff finished. Will I ever get this thing turned back in? Will I ever defend this thesis? Possibly. Who knows? Maybe it will be out. However, I'll take a tea break. I'll be back. Assuming I get the energy to get up off of this chair and go make a cup of tea. There's an article he wanted me to read for lab tomorrow, but you know, I'll be back. There we go. Intermission. Huh. Backwards. Backwards. Y'all mean this? Oh well. Customization. Can you make it so it's not backwards? You can't matter, can you? Cancel. I don't know. Backwards. Oh well. are you guys doing laying down on the job? Don't you know we got a thesis to finish? All right, where was I? Chapter 4, Results. The results of the dust cave microartifact analysis is presented in multiple ways. This includes ubiquity, box and whisker plots, and analysis of variance, and two-tailed t-tests. Ubiquity of artifacts by feature type are presented for different occupational periods, Paleo-Indian through early Archaic and Middle Archaic. The following data are first examined by feature type, following a more nuanced look. At feature types grouped by the same occupational components following the analysis are examined by feature type, then a more nuanced look, then we take a more nuanced look at feature types grouped by the same occupational components. Following the analysis of the archaeological record, the experimental cooking, first examined by feature type, then we take a more nuanced look at feature types. How about by feature types? More nuanced look. The following data are first examined by feature type. By feature type. By feature type. The data are first examined by feature type, then changes in artifact. Then we looked at changes in artifact density over time. Following the analysis of the archaeological record, the experimental cooking is analyzed. This includes a visual and written description of the effectiveness of using the pit, hearth, and expedient hearth to process nuts and snails, and a quantitative analysis of the micro-artifacts associated with the replicated expedient and pit hearths. Comparison by feature type. Ubiquity. Tables 5 and 6 show the ubiquities of burned bone, gastropod, lithic, mussel shell, nut charcoal, seeds, and wood charcoal for the 2 to 4 millimeter sized grade micro-artifacts associated with the earlier occupations of the cave, Paleo-Indian, early side notch, and Kirk stem components. Tables 7 and 8 show the ubiquities for their 4 to 6.35 millimeter counterparts. Seed and mussel shell are the least ubiquitous, while lithics, burned bone, and gastropod shell are the most ubiquitous, being found in all 3 hearth types, expedient, pit, and surface, from all components. You might see about combining, so comment from advisor. Combining the tables somehow so it's easier to compare the size grades. Not critical, bit awkward to compare down page, a lot to digest. Not sure you need to break up the size grades for ubiquity. You just combine this and it'll be easier to follow. Combine this. Okay, so you have 4.6, 4.6 is your surface. Yeah. Time. No. Five and six. So 5, 6, 7, and 8. So the earlier occupations of the cave. That's 3, 5, and 6. Oh, that's not right. Table 5 shows the ubiquities of burned bone these things for the 2 to 4 millimeter size grades associated with the earlier occupations of the cave. Table 6 shows the ubiquities of the same artifacts, microartifacts, for the same microartifacts associated with the later occupations of the cave, i.e., Middle Archaic, even more mountain and bent. Table 7 and 8 show the ubiquities for their 4 to 6.35 millimeter counterparts. How would I combine those, though? Surface hearth. Oh, I see. Could do that. Type. Would make more sense, maybe. Yeah, maybe. Alternatively, you could just combine this and your call, pick up size grades. Well, wouldn't it be 100% about? Wouldn't be 100%. But suppose I did surface. Suppose I did. Surface hearth. Two to four and so forth. Yeah, why don't we do that? Surface hearth. So if we did surface hearth 2 to 4 millimeter, 4 to 6.35 millimeter. It will be 100%. 100%. earlier types up to Kirk's down. Okay, so that's 100. Gastropods 100 for both. Both. However, at 0%. Mussel shell and 100 again for nut charcoal. Seed is 50%. Wood charcoal. %. I see that's a big difference. Ash is at 100%. Ubiquity, some of the data is just missing altogether, you see. And different size grades. Especially things like mussel shell and seed. Nut charcoal, 67% there. Look at those numbers. Look at those differences. 100% to 0%. If you're not looking at all the size grades, who knows what you're missing? Wood charcoal, 67%. Ubiquity of artifacts found in early feature types. It's crazy. Well, there's less features. We looked at less features. So of course it's going to be down. I mean, you looked at 4 there and 2 there, right? 3. Yeah, okay, so but here you looked at 5, 5, and then 1, and 4, and 3. I just don't want to compare those things. Maybe. Because why would it consistently underrepresent? The ubiquity, if the ubiquity is divided. Statistically, it shouldn't make a difference. So, See, this is n equals 4. It's 4 for this one. A mussel shell, see, 25%. Yeah, these are the same numbers. Not charcoal, 100%, 100%. I mean, this is certainly 5%. Wood charcoal, 100%. These are all 100% down the seed. Not charcoal, 100%. Mussel shell, 100%. So there's a little bit of there too. 100%. Seed is 67%. Something with wood charcoal. All right. So this is same deal, 2 to 4 millimeter, 4 to 6.35 millimeter. 2 to 4 millimeter, 4 to 6.35 millimeter. 2 to 4 millimeter. Four to 6.35 millimeter. Okay. What's the difference? Wait. Oh, I see. Okay. You can be just a little, there we go, just a little bit wider, right? You can be anything your heart desires. All right. You can be a little wider, just a little wider, right? Just a little bit, so that we can see the 2. Can I see the 2? Why can't I see the 2? What is this? Where's my 2? There's a 2. There, it's gone now. There, it's back. So I suppose I accept this. Suppose I accept this. It's still gone. Why can't I see that? There we go. 2 to 4. There we go. All right. So we can take out this. Now we just have 2 tables. Everything is compressed into 2 tables that show us some fun things. Artifact density by feature type. All right. Thereby lending support to the fact that we need to do more microartifact analysis at different size grades. Because if we had looked just at the 4.6, 4 to 6.35, we wouldn't have found any of the wood charcoal or any of the mussel shell. I mean, the early feature types. The box and whisker plots in figures 19 and 20 compare the context in each of the 3 feature types studied: expedient hearths, pit hearths, and surface hearths. This comparison is made based upon the 2 to 4 millimeter micro artifacts and the 4 to 6.35 millimeter micro artifacts, looking at the data from all occupational components together. Significance of the differences among hearth types are evaluated using ANOVA. Graph, table, note to self, who knows, except, whoops, let's just delete that comment. Table, formatting stuff. Graph, table, artifact density through time. What was this? A more nuanced approach to the data is to compare the artifact densities between early and middle archaic occupations of Dust Cave. Figures 21 and 22 present box and whisker plots of the 2 to 4 millimeter microartifact densities associated with specific features for the late Paleo-Indian, early Archaic, blah, 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 and middle Archaic occupations. So there's the caption. Surface hearths, 2 to 4 millimeter microartifacts. Figure 21. Don't understand. Not any pit hearths. Delta Kirk stem component. That's not pit hearths. These are surface hearths. But time period comparison makes sense to organize by time period. So one for surface hearths. Various periods represented. Another for pits. Unorganized by feature. I wonder if I changed that. What's going on with these hearts? I just didn't have data, so I don't know what to do about that. For 4 to 6.35 millimeter expedient hearts, I only have one. Yeah, not sure what to do about that. Significance. The differences. Artifact density is analyzed using ANOVA. The results for the earlier and later occupation represented tables 9 and 10, respectively. Oh boy, same procedures were done for these. Gastropod shell. What do I do? What do I do? I'm not gonna get this done tonight, but when am I going to get it done? Here's a few random thoughts. Try to organize it either by artifact type or by feature type. Oh, I don't know. It's just getting too late. Little of the gastropod shell was lost during processing, either when steaming on the expedient hearth or boiled in a pit hearth. Much of the damage that occurred to the shells happened after the snails had been removed from the cooking features and then transported for analysis. When removed from cooking, the shells were more fragile after being roasted on the griddle and boiled in the pit. Despite this, more remains were recovered from the pit than from the expedient hearth replication. In fact, Figure 34 shows that no gastropod shell remains were recovered in the expedient hearth, indicating either that the visible damage occurred during the process of handling afterwards, or that shell fragments lost in situ were of a size less than 2 millimeters. Color changes were evident following the cooking procedures for both. Those that had been steamed remained lighter in color, except where the shell had obviously been scorched or burnt. Both cases, color change. It is a thesis that doesn't. Right. For example, is there color change? So, standardize the info. Color texture changes, overall preservation size remains. Color texture, overall preservation size remains. Okay, color and texture. Back a little bit. Gastropod. Preservation. There's so many comments, and this is supposed to be like the final draft. But I got really soon. shell remains so gradual. Gastropods. More shells are recovered from the pit and the expedient Hart's replication. In fact, figure 54 shows no gastropod shell remains recovered in the expedient hearth, indicating that. Okay, yeah, so I see. Probably want to do something like that. So if we take this Bambino, put it here. Figure 38. Seemed to remain lighter in color, except where obviously burned. See. See figure 39. Preservation. Mastering and processing, either when steaming, blah, 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 blah. So this was, well, anyway. $34, $35, $36. Chapter 5, Discussions and Conclusions. Overall trends. There are several noticeable trends when looking at the dust cave microartifact data. First, the majority of the features examined contain most of the artifact types. This could indicate that the features are more varied in use than originally suggested by Holmes in 2004. It's also possible, however, the excavated fill and the features are secondary deposits, referees from activities occurring elsewhere at the site. Second, mussel shell and seeds are noticeably rarer than the other microartifacts recovered from the features. This could be the result of dietary preference. It could reflect seasonal variations of availability of mussels and seeds, possibly as they're not available at times of the year during which the cave is unused. It's also possible that seeds and mussels experience poor preservation over time than other artifact types. It seems from handling a mussel shell might be more durable than, for example, gastropod shell, which there's abundance. Third, despite some changes in microartifact density over time, the same types of food resources are found in the features from late Paleo-Indian through Middle Archaic occupations. These frameworks remain relatively consistent. And types, let me italicize, types of food resources are found. Possibly preparation techniques as well. Possible exception increases the use of nuts and gastropods in the Middle Archaic. The use of food resources. Although the intensity may have changed. The intensity, of some resources. Although the intensity the importance, although the relative importance, some reporters may have changed. For example, there is an increase in the use of nuts and gastropods in Middle Archaic, and a shift to gastropod abundance from surface hard towards pit and expedient. I wonder if it still says that. Surface hard. Yeah. There are several noticeable trends when looking at the dust cave microartifact data. First, the majority of the features examined contain most of the artifact types. This could indicate that the features were more varied than originally suggested by Holmesy. It is also possible, however, the excavated fill from the features are secondary deposits of the refuse from the activities occurring elsewhere at the site. The second, mussel, shell, and seeds are noticeably rarer than the other microartifacts recovered from features. This could be the result of dietary preference. Blah, blah, blah. Third, despite some changes in microartifact density over time, the same types of food resources are found in features from the late Paleogene and through the Middle Archaic occupation. This suggests that the use of food resources remained, that the use of food resources, that the types of food resources remained relatively consistent over time, although the relative importance of some resources compared to others changed. For example, there is an increase in the use of nuts and gastropods in the Middle Archaic, discussed below, and a shift of gastropod abundance from surface hearths towards pit and expedient hearths. So gastropod. Okay. Doesn't really matter, I suppose. I just don't know. They want me here overnight in the university still. Somebody's wandering around out there. I can hear them. Been going for 2 hours and 46 minutes on this read through. Increase in use of nuts and gastropod in archaic. Should the gastropod sort of expedient hard, the blend of a gastropod shell recovered from expedient hard line supported by hypothesis that service use of snails. Please note of archaic final observation that analysis of microartifacts has allowed for a more nuanced interpretation of food processing in Dust Cave. Here's food processing systems in Dust Cave. But there is a dramatic increase, so this should go somewhere. Let's make this separate. Difference between microartifacts size, blah, 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 blah. In most cases, both gastropod nutshell, higher density. Echoing the suggestion made by Thomas and Menina, 2015. Here. Yes, that's what I would suspect. I'm growing weary. I still have to do a lot of labeling of things and making up list of figures, tables, and formatting. I'm growing weary. I gotta quit tonight, I think. Well, thank you for your viewership. Farewell and such.